Hi. In this video, we are going to be working more with the unit of electricity. I am going to explain a little bit more about the motion of electricity and electrons. The first point that we have here is that the electron was discovered by J.J. Thomson. This is the picture that we have right here. That is the first one. He's really famous since he was who discovered the electron. But then we have Robert Millikan and his student Harvey Fletcher, and they found the value of the electron, the charge of the electron, that if you remember is equal to 1.6 times 10 to the negative 19. And this is right here is Millikan. Now, to be able to understand how the electrons work or how the electricity can have the motion from one point to another point, we need to understand how are the solids. Now, the solids, using the definition about using atoms, are a form of matter where the nucleus is a fixed structure. Now, what that means is when we have a solid, let me say it right here, this is one object, a solid, and all these squares are atoms. The nucleus of the atom is fixed. That means these circles right here are the nucleus of the atom. They are fixed. That means this nucleus cannot move. It's going to be always at the same position. Now, if these nucleus are fixed structure, that means that protons and neutrons, they are also locked in this position. Okay? The nucleus, protons, and neutrons, they are locked in that position and they cannot move, and this is what will create a solid. Now, solids are classified in conductor, insulator, and semiconductor. Now, since this is a basic physics class, we're going to be working with conductor and insulator, not with semiconductor. Maybe next week I'm going to give you a little bit more like examples about semiconductor, but right now I want you to understand what is a conductor and what is a insulator. Point number 5 is conductors. Now, in a conductor, electrons move freely inside the solid, and this is the more important part. Electrons move freely inside the solid. Let me try to explain here in an example, and then I'm going to explain the other points. Right here, I have a draw. You can see right here, where I am trying to simulate a solid that is a conductor. Now, if in the left we have a lot of electrons. Now, if you remember, the electrons, since they have the same charge, they don't want to be together. I mean, what is going to happen with this electron that right here in the left corner of the solid is they want to move away from this electron. That means they're going to move away. Since on the left we have a lot of electrons, on the right we have less electrons. That means they're going to be moving to the right here. Now, what will happen with these electrons that are now in the center? They are feeling the electrons that are close to them, and they're going to also what? Move far away. Now, here comes the problem. These electrons that are right here in the corner, they're going to try to go to the what? To the surface as far as possible. But the key right here is that these electrons in the corner, they're going to go to the surface, try to go as far as possible from these electrons that were in the left at the beginning. Okay? And this is how a conductor, the current can go, in this example, from the left to the what? To the right, since the electrons have the same charge and they don't want to be together, and using the point that the electron moves freely, that's why they're going to try to move as far as possible. Now, if you see right here, the second line sentence say, like charges repairs, therefore the electrons tend to spread as far as possible, which means that they will move to the surface of the conductor. Okay? Exactly what I was trying to explain. Now here we have three examples. The first example is copper. Copper is one of the most common materials that we've been using for years for electricity. Normally you're going to see it in the charger for your iPad, the cell phone. Most of the regular wires that we use for covering, we're going to use copper, since it's a really good conductor and the electrons move really fast in this conductor, and it's not that expensive. Right now it's really expensive, but before it was not that expensive. Then in the second example right here, we have these wires. These wires that we have right here, guys, these are the wires that we use to move the covering from the plant of electric plant, to your house or our school or, come on, every single place. Now here they use a combination of material. They're not going to be only copper. Normally they mix a different type of material depending how much electricity they need to move to try to create the best conductor as possible. Okay? And the third example right here is gold. Gold is really good. Gold was not that expensive years and years ago. Right now it's really, really expensive. That's why people don't use it that much. But it's a really good conductor. Normally it was used more for electronic, the microchip of the cell phone, not cell phone, but before that, like watch, TV, everything that I've been using, like computers, a lot of motion or electricity, but something really small, they were using gold before, since it's a really good conductor of electricity. Now, for conductor, what you need to remember, electrons move freely inside the solid, and they're going to move as far as possible close to the surface of the object. Okay? Let's go to the last one. Insulators. Insulators are materials that have strongly bound electrons that can move only short distance in the solid. Let's say, go right here to the sample. We have right here the object. We have right here the electrons. Let's go again to read the first sentence. Insulators are materials that have a strong, keyword, bound to the electron, and they can only move short distance. See what happens. If I have a lot of electrons in this corner, on the left side, now, the electrons that are close to this side, they're going to try to move. And yeah, be careful, they can move, but they can move only what? Short distance. I mean, they're going to be moving to right here. Now, what happens with the electrons that are in the center of the object? They're going to feel them. And what they're going to do, they're going to move a little bit. Now, the last electron in this object right here, since these electrons are not that close, they are not going to move, because the second electrons, they don't went that close to them for them to try to go as far as possible. That's why the covering, it will start on the left, it will start going up, 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 but then right here, it will what? Stop, and it will not be able to go from one side to the other side of the object. Okay? Why this happen? Since the electron have what? A strong bound in the material. That means they can only move really short distance, and that's why we call them insulators. Okay? Now, going to the second sentence right here will be that it will be harder for charges to move any significant distance. That means they will be able to move, but the distance will be really, really small. Now, different insulator, we have a different level of insulation. That means that depending on the material that you use, the electrons are going to be moving more distance or less distance. Okay? Now, right here I have three different examples. The first example is glass. Glass is a really good insulator. The electrons are strongly bound. They only move a really small distance. It's really good. People don't use it a lot since the glass can break. But before we'll be using glass a lot. Right now, not really. That depending on what we're doing. But glass is a really good insulator. Second is rubber. Rubber is really good. Where you can see rubber and your shoes. That's why if it's covering on in the floor, in the water or something, and you're walking and you have shoes that have that the bottom is rubber, you're good. All the gloves are made of rubber. The screwdriver, the an electrician use, they're going to be using rubber. Why? Because then the electricity don't go from the wire to the body. Let me see here an example. We have right here a wire. Then we put rubber on top. And then what happens is when you touch with your arm, right here, the current doesn't go from the wire to your arm, since this rubber that is on blue right here stop the motion of electricity. Okay? That's why all the wires have a rubber around the wire, and the glove, the screwdriver, they're always using rubber to try to insulate the object, and then you will not have an accident with current. And the third example right here is ceramic. Now, ceramic right here is really good. It's being normally used for insulators that are going to be working with a lot of electricity. Right here, this one is normally to stop lightning. When it's a storm, and then all this lighting can go right here and have a collision with the wires of current that are going to your home. All this current will try to go to your home and be moving in the wire, and then this ceramic will stop the motion of electricity, because all the electricity from a storm, if go to your house, can easily burn the whole house. Okay? I mean, ceramic is an amazing insulator. It's really good, and we normally use a ceramic for things that are going to be working with a lot of electricity. Now, going back to insulator, that you need to remember, this material have a strong bond of electrons, and they can only move short distance. They can move, be careful with that. Okay? Now, that's it for today.